Alright, Max, so this is a one-on-one Miss Parrott video for you about how to do chi-squared stuff on a test. Okay, so I gave you this one on version 2 of the test, and when I asked you did you have any questions, you were like, no, but you totally did, and you didn't ask me. So I'm going to show you how to work through this, and you're only going to see the paper and like my handwriting, okay? But on this one, so the first thing we want to note, probably get something to write with, okay, is that this is telling us that we have a mom who is wild. So we're going to know that our mom is wild. I'm going to put that plus for wild type. And our dad has lobe eyes. I'm going to make that L. Right? So the big questions we're trying to figure out is our mode of inheritance autosomal or X-linked? So which one of those it is? And then once we figured that out, is it dominant or recessive? Alright, so we're trying to figure out what combination of those two things is true for lobe eyes. Alright, so we know that in our P generation, again, we have a wild mom and a lobe-eyed dad. And then in our F1, we have 622 wild-type males, no wild-type females, no lobe-eyed males, and lobe-eyed, a big group of lobe-eyed females. So these are split pretty much half and half. Now, anytime you see something where there's a big discrepancy between like males and females and like their grouping and phenotype, that's just an ultimate automatic signal of X linkage. Now, that can happen whether it's true in the F1 generation or in the F2. If you see like weird groupings, males different than females, that's going to let you know that it's X-linked. Okay, so if that's the case, then we can make our parents be, so let me see, I'm going to do my parents, my mom, she is XX, right? And my dad is XY. And if mom is wild, she's going to be homozygous for wild. And my dad is going to have lobe eyes on his X chromosome. Remember, if this is an X-linked trait, we're not going to have anything on the Y. That's important, and, you know, because otherwise it's not an X-linked trait. So if this is true, if I Punnett squared that out over here, let me get mom up here and dad over here. The dad's lobiness and mom's wildness. So I've set that up, and if I fill it in quickly, then I'm going to have lobe. Okay, so if that's the case, then now I have, according to my Punnett square, if those are my parental genotypes, I'll have all wild boys and I have all lobe-eyed girls. So lobe-eyed female here, wild-type male here. So what this tells us, with the fact that we have our girls are heterozygous, meaning they have one lobe and one wild allele, and the fact that those girls who are heterozygous show the lobe-eyed trait tells us that lobe eyes is dominant, right? If wild type was dominant over lobed, then our girls would all be wild type, but they're not. So right there, we can, this is now our hypothesized mode of inheritance that we would use. We would hypothesize that lobe eyes is X-linked dominant. Alright, and to be sure, if we mated, right, the individuals from F1 were then crossed to produce the following offspring. These ones here, if I did a little cross here, and had a wild dad and a heterozygous mom for lobe, I would have 25% in each phenotype. So this right here is a homozygous wild type female. That's 25%. And like out of, I think this is 1,210 flies. And you can see that's divided up pretty close to 303 each. So, right, 25%. The girls are different, and then the boys have different phenotypes. This one has lobed, this one has wild, so we got half and half over here. So if our mode of inheritance that we predict is X-linked dominant, then all these numbers make sense. Okay, so that's A, we've determined the parental genotypes, and we've identified the mode of inheritance, right, X-linked dominant. And now, I mean, this is what we think it is. This is what we hypothesize. But now we're going to use a chi-square analysis on the F2, so this data right here, okay, to analyze their prediction, showing all my work and explaining. Okay, I'm going to do this on the next page. Alright, so this will be given, and I'm going to come back and we'll be able to look at the distribution chart to determine our final results. Okay, so let's look at our F2 numbers. Alright, so this is 1,210 total flies. If our mode of inheritance is X-linked dominant, we would expect 25% of each. 25% of 1,210 is about, it's like 302, like, so our expected is like 302.5, but there's no such thing as 302.5 flies, so we'll let 2 of them be 302 and 2 of them be 303. Okay, so we're going to figure out our chi-square value is going to equal, well, I have 4 groups. So I'm going to be sure I'm going to have some action going on here. I'm going to set it up for 4 groups. So get my game face ready. Okay, so these are, we're going to have our wild males. This is going to be our male wild type, female wild type. This is going to be our male lobe eyes, and then our female lobe eye flies. Okay, so these numbers are our observed, right? The ones that were given on the paper. And again, if we have 1,210 flies and we Punnett squared out, we would expect 302 or 303 of each. So if we remember, chi-square equals the sum, which means, right, we're adding all this up, of our observed minus expected squared over expected. Alright, so our observed male wilds is 307. So observed 307 minus our expected 302, divided by our expected 302. Alright, female wild, we have 318 minus, again, our expected 302. divided by 302. Alright, male lobe. Observe 297 minus 30, we'll do it 3 this time, divided by 303, and then 288. Female lobed minus 303 over 303. Alright, it's calculator time. So now, because in the FRQ, now we had to use a chi-square analysis to analyze my prediction, show all my work, and explain why it works. So you get 1 point just for setting it up. Alright, then you're going to get another point for showing this work. So I'm going to do that really fast. Right, okay, so I got 307 minus 302 is 5 squared, that's 25. So 25, how about that? Okay, so 25 divided by 302, yeah, that's pretty small, 0.083. 0.083 plus, now we do this one, alright, 318 minus 302 is 16 squared. Don't forget squared, you times it by itself. You ask me that every time. So to square something, you just times it by itself. So now we got 16 squared is 256 divided by 302 equals 0.848. 0.848 plus, alright, 297 minus 303 squared, right? 297 minus 303 equals negative 6 squared, so it's a positive number, right? So that's going to be 36, right? Divided by 303. That shouldn't be negative. I don't know what happened, why that's negative, but imagining it's positive, 0.713, 0.713 plus 288 minus 303 is negative 15, right, times 15 equals 225 there, divided by 303 equals 0.743. Alright, so now we need to add all this up. So let's do it. Alright. 0.083 plus 0.848 plus 0.713 plus 0.743 equals 2.387. Alright, so chi squared equals 2.387. Awesome. Okay, so now the question is, so what, right? So this is when we're going to use our chi-square distribution chart. All right, so we had 4 groups, 1, 2, 3, 4. All right, and so that means to figure out our degrees of freedom, I'm sorry, not D4, D freedom, degrees of freedom, right? It's going to be 4 groups minus 1. Right, equals 3, so we know which place on the chart. Alright, so we always want to be 95% sure, so we're going to use this 0.05 column. We have 3 degrees of freedom, 1, 2, 3, so we're going to go over. Alright, a critical value is 7.81. Alright, so, and if we recall, if our chi-square value, which we just figured out was 387. Okay, so if our chi-square value is less than the critical value, right, then we accept our hypothesis, right? So, and if it's greater, we don't. So 2.387 is much less than 7.81. So, what we would say on letter C, right, explain why the results support or reject your hypothesized mode of inheritance. We would say that since chi squared equals 2.387, and that is less than the critical value of 7.81, right? That's the critical value. We can accept our hypothesis that lobe eyes is X-linked dominant. Alright, and so that's how we would work this. I gave this a pretty hard problem because it was the second time around. Alright, but this is what I want you to do. You're going to take notes on this video. You're going to make organized notes of all this stuff that I just did. Okay, and then we are going to sit down and work on another one together. It's going to be easier. Alright, but it's important that you know how to use this formula and that you can use reasoning with data to be able to figure out modes of inheritance. You will see this on the AP exam. It's going to happen, and I believe that you can learn it. Alright, I'll send this to you in an email.